Hello everyone, welcome to the next lab. You can find the link of this lab in the description. So let's start the contest. The first question is server room emergency. Evelini has got his hands on some very sensitive information. If this information is misused, it can cause mass destruction. Codeman has managed to break into Evelini's server room and hack into the server. To decode the files, Codeman needs a prime number. He looks around and finds a number written on a slip. Help him identify if it is a prime number or not. So we are given a number and we need to identify if the number is prime or not. In the input format, we are given a single integer, and in the output, if the number is prime, we need to print prime, else we need to print not prime. So let's see the first example. So let's see the test case 0. We have the input 2. 2 is a prime number, so the output is prime. In the next test case, we have 8 as input and the output is not prime. So let us start coding it. So first we will make object of scanner class. So the scanner sc is equals to new scanner system.in. So now we have to take an integer as an input. Int n is equals to sc.nextInt. Now if I want to check if the number n is prime or not, I need to check that n should have only two factors, that is 1 and n itself. So from 2 to n minus 1, n shouldn't have any factor. So I'll check for int I is equals to 2, I less than n, I plus plus. Now for all the values of I, n should not be divisible by I. If n is divisible by I, in this case I can directly print that the number is not prime. So I'll write system.out.print not prime and I'll return from the code. That means the main function execution will stop here. So I'll write return. Now if I have come out of the for loop and n is not divisible by any I, this means that the number n is prime. So here I'll write system.out.print prime. Let us run this code. The sample test cases have passed. So if I want to optimize this code, I need not check from 2 to n minus 1. I can check till n by 2. Further, if I want to optimize, I can also check it until square root of n. Because if n has any factor that is greater than square root of n, it must have a factor that is less than square root of n. So if no number less than equal to square root of n divides the number n, then no number greater than square root of n can divide that number. So here we can optimize it, that I is less than or equal to math dot square root of n. Let us now try to run this. The sample test cases have passed. Moving on to submitting this code. All the test cases have passed. Let us now see the next question. The next question is Shizuka and the campus placements. Shizuka has taken part in the campus placement drive taking place in her college. She has been studying all week for it. She has almost completed the syllabus and is left with just one problem. She needs to find prime numbers within the given range in the last remaining problem. Help her out by finding its solution. Note, if the range does not exist, print invalid input. So here we are given two integers a and b, which denotes the start and end of the range, and we need to print all the numbers from a to b which are prime. So let's see the first test case. It's 1 and 10. So starting from 1 going till 10, I have 2, 3, 5, 7 as the prime numbers. In the next test case, we are given the start of the range as 18 and end of the range as 30. So starting from 18 and going till 30, we have 19, 23 and 29 as prime numbers. So they are displayed in the output. So let us try to code this. First, we'll make an object of scanner class by writing scanner sc is equals to new scanner system.in. Now let us take two integers as input denoting the start and end of the range. So int start is equals to sc dot next int and int end is equals to sc dot next int. So first we'll check the condition if the range exists or not. So in case this end value is less than start, then the range does not exist. So in this case we will print invalid input. So I'll write system.out.print invalid input and I'll return from here. So if the control reaches outside the if block, this means that the condition was not true. So end is greater than start, so range exists, and we need to find out all the prime numbers in the range start to end. So I'll start a for loop for int n is equals to start, n less than equal to end, n plus plus. So here n will take all the values from start to end inclusive of both these numbers start and end. So I need to check if n is prime and I need to print it, otherwise I'll skip this. If n is negative or 0 or 1, that is if n is less than or equal to 1, in this case I need not check that the number n is prime or not. So I'll write a condition if n is less than equal to 1, I'll continue. So continue means I'll go to the updation part of the loop, so I'll go to n plus plus. So how will I check if n is prime or not? I'll again run a loop starting from 2 going on till square root of n. So I'll take a loop for int I is equals to 2, I less than equal to math dot square root of n I plus plus. Now if n is divisible by I, so in this case n is not prime. Now if n is divisible by I, this means that n is not prime. So I can take a variable. So let us say I take here a variable flag and I'll keep it 0 in the starting. So if n is divisible by I, I'll make this flag variable as 1 and I'll break from this loop. Now after coming out of the while loop, I can check the value of flag. If flag is 0, that means the if condition never got true. That is, the number is not divisible by any I. So if flag is 0, that means this number n is prime. So if flag is 0, I'll print n system.out.print n and then I'll give a space, and if flag is 1, that means the number n is not prime and I will not print it. So let's run this code. The sample test cases have passed. Let's submit this. So all the test cases have passed. Moving on to the next question. The original problem statement where Fibonacci series appear for the first time in modern period is a very interesting one. It was a book by Leonard of Pisa, also known as Fibonacci, named Liber Abaci 1202, which brought such interesting series to the popularity. Fibonacci considers the growth of an idealized, biologically unrealistic rabbit population, assuming that a newly born pair of rabbits, one male, one female, are put in a field. Rabbits are able to mate at the age of 1 month. So at the end of its second month, a female can produce another pair of rabbits. Rabbits never die and a mating pair always produces a new pair. One male, one female every month from the second month on. The puzzle that Fibonacci posed was, how many pairs will there be in 1 year? At the end of the first month, they mate, but there is still only one pair. At the end of the second month, the female produces a new pair. So now there are 2 pairs of rabbits in the field. At the end of the third month, the original female produces a second pair, making 3 pairs in all in the field. At the end of the fourth month, the original female has produced yet another new pair. The female born 2 months ago produces her first pair also, making 5 pairs. At the end of the nth month, the number of pairs of rabbit is equal to the number of the new pairs, which is the number of pairs in month n-2 plus the number of pairs alive last month n-1. This is the nth Fibonacci number. The series can be broken down as the following series. We have Fibonacci of 0 as 0, Fibonacci of 1 as 1, and Fibonacci of n as Fibonacci of n minus 1 plus Fibonacci of n minus 2 for all n greater than 1. First few elements of the Fibonacci series are 0, 1, 1, 2, 3, 5, 8, 13 and so on. Here given an integer n, print first n Fibonacci numbers. Note, if the given number is negative, print invalid input. In the input we are given a single number n and we need to print the first n numbers of the Fibonacci series in this question. So for example, in the first test case we are given number 2. So the first two numbers are 0 and 1. So in the output we are printing 0 and 1 separated by a space. In the next test case where the input is 4, we are printing the first 4 numbers of the Fibonacci series. So let's try to code this. So let us first make an object of scanner class to take the input. So I'll write scanner sc is equals to new scanner system.in. Next I'll take an integer n as input. So int n is equals to sc.nextInt. Now if the given number is negative, we need to print invalid input. So if n is less than 0, in this case we will print invalid input. So I'll write system.out.print invalid input. And I'll return from the main function. If n is equal to 0, we need not print anything. So now let us take two integers a, that is the first number as 0, and the second integer b, that is the second number of the Fibonacci series as 1. Now if n is greater than or equal to 1, we'll print the first number system.out.print 0. Print the first number, that is a. We'll print a and then give a space. For the remaining numbers, I'll use a for loop. For int I is equals to 2. So I want to write from the second number I less than equal to n I plus plus. So first I'll print the second number, that is stored in b. So I'll write system.out.print b and then I'll give a space. Now I need to calculate the next number, that is the sum of a and b. So let's take another variable c for this. C is equals to a plus b. Now I'll update the values of a and b. The previous value of b will go into a and the new value of c will go into b. So I'll write a is equals to b and b is equals to c. And this will continue until I reaches n. So let us try to run the code. The sample test cases have passed. Let us submit this. All the test cases have passed. Moving on to the next question, that is the rotation policy. English team has now adapted a rotation policy for two of their players, Dom and Leach. On the first day, both of them played, but from the second day, Dom plays every second day, while Leach plays every third day. For example, day 1, both are playing. Day 2, none of them plays. Day 3, Dom plays. Pen चाहिए होगा. Day 3, Dom plays. Day 4, Leach. Day 5, Dom. Day 6, neither. Day 7, both, and so on. Find the number of days in the interval A to B, A and B both inclusive, when neither Dom nor Leach played. Return the number of days when neither of the two players played the game. So let's see how these players are playing the game. So let's say we have the days as 1, 2, 3, 4, 5, 6, 7, 8 and so on. So now on the first day, both Dom and Leach played. Next, Dom is playing every second day. So Dom will leave this day and Dom will play on third day. It will leave fourth day, it will play on fifth day. It will leave sixth day and play on seventh day. it will leave 8th day, and so on. Now leech will play every 3rd day, so it will leave 1, 2 and play on day 4. Again leave 2 days and play on day 7, and so on. So now we need to calculate the days when neither of them plays, like day number 2, day number 6, day number 8, and so on. So let's see how we can code this. So let's see the first test case. We have day from 3 to 8. So from 3 to 8, they are not playing on day 6 and day 8. So the output is 2. In the sample test case 2, we have 1 and 4. From 1 to 4, none of them played on day 2. So there is only one day when neither of them played. So the answer is 1. Let us try to code this. First, we'll make an object of scanner class. So I'll write scanner sc is equals to new scanner system.in. Next, I have to take two numbers as input denoting the start and end day. So I'll take int start is equals to sc.nextInt and int end is equals to sc.nextInt. Now we can close the object of scanner class as all the input is taken. So I can write sc.close. Now I need to check from day number start to day end. So I'll take a for loop for int. Let's take the variable day. So days from start and day less than equal to end, day plus plus. Now what are the days when DOM plays? So DOM is playing on every odd day. So when does DOM does not play? On every even day. So if day mod 2 equal to 0, that means the day is even. So DOM will not play in this day. So now let's see the days when leech does not play. So leech is playing on day number 1, 4, 7. So when I divide these numbers by 3, I'll get the remainder 1. So leech is playing on day numbers when modulo with 3 gives us 1. So what are the days when leech does not play? When day mod 3 is not equal to 1. So for leech to not play, we should have the condition day mod 3 not equal to 1. So DOM doesn't play on an even day and leech does not play on a day when divided by 3 gives the remainder 1. So if both the conditions are true simultaneously, it means neither DOM plays and nor leech plays. So if this is the condition, we'll add it to count. So let's take a variable count and initialize it to 0. And in this case, I'll increment the value of count. After my for loop is over, I can directly print the value of count. So system.out.print count. Let us try to run the code. The sample test cases have passed. Let us submit this. All the test cases have successfully passed. Moving on to the next question. So let us see the next question, that is Kazama goes shopping. The problem statement is Kazama went to the market to buy n apples. He found two shops, shop A and B, where apples were being sold in lots. He can buy any number of the complete lots but not loose apples. He is confused with the price and wants you to figure out the minimum cost to buy exactly n apples. Help Kazama to calculate the minimum cost to buy exactly n apples. If there is no such way to buy n apples, print invalid input. And the input format is the first line of the input contains an integer n that represents the total number of apples that Kazama wants to buy. The second line consists of two space separated positive integers m1 and p1 representing the number of apples in a lot and the lot's price at shop A respectively. The third line consists of two space separated positive integers m2 and p2 representing the number of apples in a lot and lot's price at shop B. There are no constraints and in the output you need to print a positive number representing the minimum price at which Kazama can buy the apples. So let us see the first test case. We are given n as 19. So Kazama wants to buy 19 apples. Then we are given 3 and 10. This means that in shop A, Kazama can buy apples in in lots of size 3 and the cost of a lot is 10 rupees. Next we have 4 and 15. This means that from shop B, Kazama can buy apples in lots of 4 and the price of one lot is 15. And we need to calculate the minimum price at which Kazama can buy the apples. So let us take all the cases. So this is for shop number A and this is for shop B. So let's take all the cases. Let us say Kazama buys one lot from shop A. Now if Kazama buys one lot from shop A, he'll have 3 apples and the remaining apples are 19 minus 3, 16 apples are remaining. So can Kazama buy 16 apples from shop B? So yes, 16 is divisible by 4. So Kazama can buy 4 lots. So Kazama can buy 16 apples from shop number 2. So if Kazama has to buy 16 apples from shop 2, how many lots he need to buy? He need to buy 16 divided by 4, that is 4 lots. So what will be the total cost? The total cost will be, he has bought one lot from shop A, the one lot costs 10 rupees, so 1 into 10, and 4 lots from shop B, so cost of one lot in shop B is 15 and 4 into 15 gives us 60. So 60 plus 10 is 70. The total cost here is 70. So let's see the next option. Suppose Kazama buys 2 lots from shop A. So if Kazama buys 2 lots from shop A, he'll have 2 into 3, 6 apples and the remaining apples are 19 minus 6, that is 13 apples. Kazama cannot buy 13 apples from shop B. So this is false. So this option is not possible. So let's say Kazama buys 3 lots from shop A. So if Kazama buys 3 lots from shop A, he'll have 3 into 3, that is 9 apples and the remaining apples are 10. 10 apples can't be bought in sizes of 4. So this option is again not possible. So let's see, he buys 4 lots from shop A. If Kazama buys 4 lots from shop A, I'll have 4 into 3, that is 12 apples and the remaining apples are 7. So 7 apples cannot be bought from shop B. So again this option is not possible. So let's see the next case. He buys 5 lots from shop A. So if he buys 5 lots from shop A, 5 into 3 he'll get 15 apples and remaining I have 4 apples which can be bought from shop B. So the cost in this case will be 5 lots from shop A, that is 5 into 10 plus 1 lot from shop B, that is 15. So the total cost here will be 50 plus 15, that is 65. Next, let's say Kazama buys 6 lots from shop A. In this case, Kazama will get 6 into 3, 18 apples and 1 apple will be remaining. 1 apple cannot be bought from shop B. So I have 1 mod 4 equal to 0 will give me false. So I cannot buy it from shop B. So the next option is, if Kazama buys 7 lots from shop A, he'll get 21 apples which are more than the required number of apples. So we have only 2 possible options. So here the cost is 70 and in this case the cost is 65. The minimum cost is 65. So let's now start coding this. First we'll make object of scanner class. So I'll write scanner sc is equals to new scanner system.in. So let's take the first input n, int n is equals to sc dot next int. Now the next input we have is the sizes of apple lots in shop A. So let's take this input in P. Next we have the cost in shop 1. So let's take it as C1. Next we have lot size in shop number 2. Let's take that in Q. And the cost of a lot in shop number 2. Let's take that in C2. Now the input part is over, so we can close this using sc.close. Now I need to check for all the lot sizes in shop A. So I'll start for int I is equals to 0. So this is that I'm taking 0 lots from shop A. And what's the maximum value till I can go? I need to go till P multiplied by I is less than or equal to N. That is, the number of lots must be less or equal to the total number of apples Kazama needs to buy. I plus plus. Here I represents the number of lots bought from shop A. If we have bought I lots, how many apples are bought? That is P into I. So what will be the number of remaining apples? It will be N minus P into I. This choice is feasible only if the number of remaining apples are divisible by the lot size in shop number B. So if it is divisible by Q, in this case, the choice is possible and we need to find out the cost. So the cost here will be the lots bought from shop A are I and the cost of each lot is C1. The number of lots bought from shop 2 are N minus P into I divided by Q. So these are the number of lots bought from shop 2 and I'll multiply this by C2. Now we have calculated the cost. We need to know if this is the minimum cost or not. So for that we'll take a variable to store the minimum value. And let's initialize it to the highest value of integer, that is integer dot max value. Now here, after calculating the cost, that is an integer variable, we need to check if the minimum is greater than cost. In this case, we need to update the minimum value and we'll make minimum equal to cost. So here we have explored all the possible cases. So in the end, we can print the minimum value. So here we are given a condition: if there is no way to buy exactly n apples, we need to print invalid input. Only if we have entered this if condition, it means that there is a way. If we have never entered this if block, it means that it is not possible to buy exactly n apples. So let us take a variable flag and initialize it to 0. So if I enter this if condition, I'll make this flag equal to 1. Now after I have checked all the possible lot sizes, here I will check if flag is 0. That means the if condition never became true. So in this case, we will print invalid input. So I'll write system.out.print invalid input. And in the else part, that means if flag value is changed, in this case we will print the minimum value. So I'll write system.out.print the minimum value that is stored in the variable minimum. So let us try to run this code. So the sample test cases have passed. Let us now submit this. All the test cases have successfully passed. All the questions in this lab are complete. Thanks for watching. See you in the next lecture.